Hello, everyone. Hope you guys are having an awesome Ignite. My name is Andrew Liu. I lead product management for Azure CosmosDB. Today, I have some awesome guest speakers here. I have Jeff, who is the VP of Architecture at Sitecore. He's going to walk us through how Sitecore builds multi-tenant SaaS applications on Azure and some of the best practices he has learned. And then following that, we will also have another co-presenter, Deborah, who will also demo some of the new innovations we're doing as Azure in this space. With that said, Jeff, take it away.
All right. Hello, I'm Jeff Iles, the VP of Platform Architecture at Sitecore. I've been building SaaS commerce systems for over 20 years. There's a lot of content out there about building SaaS today, and I want to share some of what we've learned about running it at scale. Sitecore's roots are in enterprise CMS, the old on-prem world where upgrades were painful, complex, disruptive. We've been on a SaaS transformation journey. XM Cloud migrated our CMS to SaaS, but we've also built a fully cloud-native services from the ground up. OrderCloud for commerce and content service, the engine powering Sitecore AI and SaaS CMS. Today, I'm going to use these two systems to show you two different multi-tenant architectures. Same principles, different scale profiles, different trade-offs. And I'm going to show you the problems that actually keep engineers up at 3 in the morning. You're going to see architecture diagrams that look boring and good. Boring is good in this case. You're going to hear about trade-offs, not silver bullets, because multi-tenant SaaS isn't one architecture. It's a set of principles you apply based on your constraints. And you're going to hear some war stories because interesting stuff isn't in the diagram, it's in the decisions that you can't see. By the end of this, you'll understand how to design multi-tenant systems that actually scale, what tools you need before problems happen, and why sometimes the right architecture depends entirely on what problem you're solving. So let's start with OrderCloud. OrderCloud is Sitecore's commerce-native, API-first commerce platform. Everything from simple B2B stores to highly complex B2B commerce flows live on the OrderCloud platform. One interesting example that we've had on OrderCloud is a nationwide consignment retailer with 400 locations managing over 1 million unique SKUs with a high rate of change. They handle 2 types of inventory: shared catalog items like new gear that every store sells with their own pricing and stock levels. So you can imagine large 50,000 SKU catalog multiplied by 400 stores, each with their own inventory and price. I mean, they don't all change their prices every time, but it's a possibility that we have to account for. The other type of product that they have is consignment. So person brings in a new bike that they want to sell. The person in that one of those 400 locations takes a picture, posts it up to corporate, and 3 minutes later, it's available on OrderCloud, being able to be searched nationwide via Elasticsearch. Somebody buys it across the country, it comes down just as fast. So that's the kind of real-time, high-velocity, multi-location complexity that OrderCloud handles at scale. OrderCloud is built for modern, headless microservice architectures, giving you full control over the commerce experience. And what makes it different is that everything is API first. So you can integrate with any stack. It's a true multi-tenant SaaS with enterprise scale, security, and governance handled for you. And with accelerator apps, you can launch working enterprise-ready solutions in minutes. Developers love it because you start fast and scale safely and have freedom to innovate without fighting the platform. So let's just start with some definitions. So what is multi-tenant SaaS? The textbook answer is a single software instance that serves multiple customers, multiple tenants. Well, ensuring logical isolation of data and configurations. Now, that's the definition, but the thing is, don't fixate on it when you're designing multi-tenant solutions. Multi-tenancy is a principle, not a checkbox. You'll hear debates, is it really SaaS if customers have separate databases? What about dedicated infrastructure for whale customers? Those are the wrong questions. The right question is, where does sharing make sense and where doesn't it? Share where it makes sense, separate when sharing isn't worth the trade-offs. It's really that simple. What are you actually trying to achieve? Secure, reliable, scalable, cost-effective software. That's all your customers care about. They're not going to be aware of how pure SaaS you are or not. Multi-tenancy is a tool to get there, not the goal itself. Sometimes the most multi-tenant decision is to give the customer their own database. Sometimes it's to share everything. Both can be right depending on your constraints. When it's done right, multi-tenancy gives you 3 big wins. Cost control, shared resources mean lower infrastructure and maintenance cost. That's either more profit for you or better pricing for your customers, likely both. Scalability, onboarding new customers without deploying separate infrastructure. One row in a database, not a new environment. Operational efficiency, centralized updates, monitoring compliance. You build it once, you run it once, everyone benefits from improvements. These outcomes matter. The specific architecture, that depends on what you're building. So let's show what this looks like in OrderCloud's architecture. So when I show people this diagram, I get the same reaction every time. It's boring. And that is the point. This is a very simple architecture for the problem that we're trying to solve. WAF for security, app services for compute that scale horizontally, nothing special there. SQL for persistence, Event Hub for queuing async work to Azure Functions, Elasticsearch to flatten commerce complexity and make the queries blazingly fast. App Insights for monitoring. I bet 80% of web API infrastructure diagrams look exactly like this. The magic isn't in the architecture diagram, it's in the decisions that you can't see. Here's where it gets interesting. OrderCloud is multi-tenant SaaS. Every single one of our customers, hundreds of organizations, share this exact infrastructure. New tenant signs up, 1 row in a database, and that's it. No provisioning delay, no new resources, no spinning up architecture. 1 row. Now, people always ask, do you have a tenant ID in every single table? We don't. We use foreign keys and relationships, and the tenant flows down through the data model naturally. It's just SQL doing what SQL does. But here's the key. Every single API request comes with a unique API client ID. That's our context. The client ID tells us which tenant, which user, which permissions. Everything we need to isolate that request. One tenant can have multiple API clients, giving us fine-grained control over that tenant. This is the multi-tenant payoff. OrderCloud doesn't care how many tenants we have. We care about order volume. We scale based on actual work, not customer count. The economics are incredible. Our cost of goods sold is phenomenally low because we're spreading the infrastructure cost across hundreds of customers. That's the multi-tenant advantage. You build it once, you run it once, and everyone benefits. So yes, it does look simple. Simple architectures using commodity Azure services, but the multi-tenant design, that's what makes it scale at a business level. So let's talk about a different scenario, Sitecore content services. It's the same multi-tenant SaaS principles, but different scale challenges lead to different architectural choices. Content service underpins websites with billion views per month. At that scale, everything changes. OrderCloud's shared database model, it doesn't work anymore. When you're dealing with massive data volumes per tenant, the operational trade-offs shift. So we made a different choice. CosmosDB per tenant. Each tenant gets their own database. Yes, it costs more per tenant, but at this scale, it buys us something valuable, true data isolation and the ability to offer customer-managed encryption keys. And enterprise customers love this. Even in commerce, we get that question a lot, and we have other ways to work around it, but it's not true managed keys like you can do with per tenant database in Cosmos. So again, that's only possible per database per tenant. The infrastructure looks similar, but it uses some different resources. Instead of app services, we're running Kubernetes because at this request volume, we need that level of control over pod scaling, resource allocation, and deployment strategies. WAF is still there, async work done by Kubernetes. Monitoring, of course, is still there, but Kubernetes instead of app services, and Cosmos per tenant instead of SQL. Same patterns, different scale point. So this is where it gets interesting with content service. We have state that can't be serialized into Redis, in-memory work that's expensive to reconstitute. So we use cell-based routing with an affinity algorithm in a proxy using Microsoft's YARP package. So what does this mean? When a request comes in for a tenant, we route it to a specific pool of pods, a cell, and keep that tenant's repeat traffic flowing to the same cell. The pods in the cell maintain warm caches for that tenant. It's not sticky sessions, it's intelligent routing based on tenant context. So this starts to feel like, again, the question, is this really SaaS? I still maintain it is because those cells are still stateless. If they drop off, the traffic just routes to a different set of cells. They warm up with the more expensive querying. It's just a efficiency route that we applied to our specific scenario. Again, no one size fits all for these patterns. So it gives us efficiency of stateful processing with the resilience of stateless architecture. So where's the isolation? Multi-tenant SaaS isn't one architecture, it's a set of principles. Shared context through API identity, scale by work, not by customer count, and choose your sharing boundaries based on your use case. OrderCloud shares everything because it can. Content service isolates database because it must. Both are multi-tenant, both are efficient, different problems, different solutions. So that's a couple of multi-tenant architectures in the real world. You make trade-offs based on your scale, but the core principles remain the same. So back to OrderCloud. So OrderCloud runs in 6 global regions. And before you asked, it's not primarily a load consideration, it's about compliance. In commerce, you have to respect local data residency laws, so PII needs to live in the right region. A customer is in Germany, data needs to stay in Europe. They're in Australia, Asia Pacific. It's not optional, it's required for commerce systems. The interesting part is the compliance requirement gives us a massive architectural benefit. Each region is completely independent. Think about that. If US East has a catastrophic failure, Europe keeps running. If there's a noisy neighbor problem in one region, it's contained. Those regions are natural bulkheads that failures don't cascade across the systems. And so how do we manage these 6 independent installations without going insane? And it's infrastructure as a code discipline. And I'm sure there's plenty of talks about how important infrastructure as code is, and we follow it religiously. Each region is provisioned from the same templates, the same configuration, the same deployment pipeline. We don't manually configure anything. This means spinning up a new region or an installment within a region is straightforward. And that opens up some other interesting possibilities. So I've got just a brief story about the natural conflict between sales and engineering. Sales had a large deal on the line in Australia, and at the time we were only in 5 regions, not in 6. And they came to us and said, well, this deal is big enough that it will trigger going into Australia for the data residency. And we, of course, didn't want to run it because even our engineering teams are very conscious of our COGS. It's a team-wide discipline. And so we pushed back. We said, we're not gonna install this until the deal closes. And of course, they were stressed. They were telling us the customer was uncomfortable and didn't want to sign, and we convinced them that it would be fine. So the deal was signed in the morning. That night, we pushed the Deploy Australia button. We were live in Australia. So again, same patterns as all the other regions. We know we are super confident in that process because we run it all the time. We use it for our QA environments, for our staging environments. We spin them up, we use them, we delete them. It happens daily. So on the other hand, it goes back to the same question. Is this SaaS? Now we have 6 logical installations that are running our load, and I still maintain that it is. What if now, the next scenario, what if a massive whale customer comes along that runs 10 times the order volume on the platform? And it's entirely possible when you're talking about B2B commerce at scale. You might, again, we're going back to this, you might shout, that's not SaaS. Now you've just given one customer one installation. And I still maintain that it's the same platform, same code, same API, managed by the same operations team. They just happen to have their own infrastructure because their dedication demands it. Remember, we don't care about tenants, we care about order volume and how to spread that out. With our infrastructure as code discipline, provisioning a dedicated installation for a customer is feasible. They get the isolation they need, we get the operational efficiency of managing it like any other installation. Everybody wins. So there's another scenario, is if we're running into this where US East is getting a little crowded or response times are creeping up and we're approaching the DTU capacity on our databases. What we can do now with this scenario is we could just provision another region in another installation in US East. So we end up with US East A, US East B, both in the same region, both complying with the same data residency requirements. And it's not load balancing in the traditional sense. The whole tenant lives in one installation. So we're not splitting traffic. But when we provision US East B, all new customers that go to that geo will land there. So it'll start slow, but that's the great thing about Azure. They're going to let you we just provision it at a lower cost basis, and as it starts to fill up, we just gradually increase the performance over time. So it takes time to fill up, but we can, sorry, I'm repeating myself. It takes time to fill up, but like, again, we start cheap, move expensive just as we're needed as the order volume increases. So this is the bulkhead pattern playing out at multiple levels. Geographic regions for compliance and blast radius containment, multiple installations within a region for capacity management, and potential dedicated installations for whale customers. Each level provides isolation and operational flexibility, and with infrastructure as code, the complexity is completely manageable. So, time for a reality check. Noisy neighbors. We talked about how elegant the system can be and what the benefits are with shared infrastructure and the economics and the simple architecture. Now let's talk about the downside. The noisy neighbor problem is real, it happens, and you need to have tools to deal with it. In OrderCloud, we log everything. Every API call, every excessively slow database query, every response time. We can afford to do this for two reasons. First, we have to for compliance. We're dealing with commerce, PII, financial transactions. We need to log everything. But our traffic volume allows it. We're not nearly at the content service scale with billions of requests. We can be excessive with logging and it becomes our operational superpower. This isn't optional, it's an early warning system. So in addition to logging, we also, of course, log all of the things you'd expect. The app service plans, the CPU memory utilization, API response time trends, particularly when latency starts climbing, increased 500 responses, traffic spikes outside of normal ranges, which we'll get into shortly, and failed health checks. So when these metrics start moving in the wrong direction simultaneously, we start to know something is wrong. So now it gets into some specific cases on what this noisy neighbor problem means. And this is how it almost always plays out. The engineers start seeing the alerts. The API, again, API response times climbing are a very typical scenario that we see, 500 errors increasing. We dig into app insights and see SQL deadlocks spiking. We correlate those logs back to a specific API client, and it turns out a customer's integration went haywire and is dumping massive amounts of redundant inventory records into the system. Now, the interesting part, the shopping experience, even in this scenario where they're just hammering us with these inventory updates, the shopping experience is still fine because buyers are pulling that data from Elasticsearch. So browsing is still fast, but the order submission starts slowing down because that's transactional. So we need to lock those inventory rows in SQL to maintain consistency. And that's where the pain starts showing. Our engineers will reach out to the customer immediately, any way we can, email, phone, Slack, anything. No SLA, just urgency. We work with them to understand what's happening. Often we can fix it together. Maybe we tweak a back-end process, add some throttling, optimize a query on our end. When that happens, everyone wins. The platform gets better, we learn something, the customer's integration improves. But sometimes it's just abuse. They're slamming us with redundant inventory updates and there's nothing useful to learn. In those cases, we do have to act. This is where API client infrastructure becomes critical, architecture becomes critical. Because remember, every API request comes with a unique client ID. One tenant can have multiple client IDs, one for their storefront, one for their inventory management, one for order processing. When we need to act, we can simply disable that specific API client that's causing the problem. Often the customer can't even shut down their own systems, whether their people are out of the office or they don't know why it's happening, they don't have good visibility into their own systems, super common. So we pull the plug on them. So we will surgically disable that one API client while leaving their we just fix their buying experience because we're not gonna have the SQL deadlocks anymore. Their users will stop having slow checkouts. They're happy because they can capture the orders, but their inventory records are behind. So it's not the end of the world. But again, this is an absolute must, an absolute last resort, and we always try to contact the customer. It's extremely rare for us to pull this without the customer being involved in this kind of scenario. So take that same scenario where we're getting dumped inventory records or product updates or what have you, and this is where it starts to get expensive. So OrderCloud is an eventing coordinator. When products or inventory change, we push those updates out as events. customers or even customers' own systems or even Sitecore systems subscribe to events to power things like product recommendation engines. That's probably the most common. So we queue up all these product updates to get processed by an LLM for vectorization. And that powers the recommendations engines. And this is expensive. Every product update that goes through that pipeline has a real cost attached. So when someone dumps 5 million product updates on us, and that does happen, OrderCloud tries to dedupe at the API layer, but there's only so much it can do with that volume of traffic. So the events flow downstream, the queues back up, vectorization process starts churning through millions of redundant updates, and the cost goes through the roof. So we've already disabled their API client that's dumping this on us, and that stops the bleeding at the source, but a lot of times the damage is done. There's 5 million jobs queued to get vectorized. So again, we're just the coordinator. The system itself doesn't care. It's not a lot of process intensive for us to send those notifications, but the product recommendation engine cares a lot. And it's not just the recommendation engine. Customers might be running their own, like Microsoft Shopper Copilot, and they're all consuming these events. So we've provided tools. So we basically have a circuit breaker. So we can pull the plug on the integration event at the integration event level. It's even more granular than the API client. So we see this problem of them pushing out these millions and millions of records out to their LLM to get processed. And we can just turn that one thing off. So it's not automatic. So at a technical level, the way it works is every single message that gets processed, we make sure that that integration is still active. If it is deactivated, we dump the messages into a dead letter to figure out what to do later. So this is kind of like a last resort again. And again, it's not automatic, same as the API client. We want humans in the loop for this action. But when you need it fast. And because it's at the integration level, we can shut down just for product update events and leave everything else going. So you don't want your order fulfillment system happening. So if you have super high order volumes, just because your product updates are failing, you don't want to get behind in your fulfillments. So this is circuit breakers at multiple layers. API client level, stop the bad request coming in at the beginning, and the integration event level, stop the queued work. Those are two super important processes in these SaaS systems. And both surgical, both necessary, and both as narrow as possible. So again, OrderCloud is the coordinator, but the downstream systems is what we're trying to protect here. Now let's contrast this with content services and their Cosmos per-tenant model. With noisy neighbor problems there, it's isolated to one tenant by default. Their database, their problem, right? It sounds great, but no, it's not their problem. This can get lost in support. So one customer's having a problem, red flags don't get raised. If it's all in one tenant, it's a fire drill. And again, we want to know about these problems before the customer do. So especially in if you're sharing resources, your teams are going to be especially careful about making sure that they're the first ones to know, not the customer. So again, you don't want these things to get lost in support. If they're festering, customer is going to be upset. And the critical cardinal rule in SaaS is the customer cannot find the problem first. Whether you're shared infrastructure or isolated databases, you need to find the problems before they do. The architecture changes, but the operational requirement doesn't. So multi-tenant shared infrastructure works, but only when you have the tools to protect it. Excessive logging and observability, real-time monitoring and alerting, granular identity and segmentation at multiple layers, and the ability to act surgically without collateral damage. You'll regret not thinking about these ahead of time and thinking that you can retrofit them. Make them part of your design from day one. And modern SaaS isn't just about compute and storage costs anymore. It's AI vectorization, LLM processing, third-party services. When one tenant makes a mistake, it can cost you thousands of dollars in processing. You need to control these things surgically at every layer. So yes, noisy neighbor is a real problem, but it's a solvable problem. You need to build the right tools. You need to build them early. And because when 3 a.m. comes around and 5 million events are in your queue, you'll be glad that you did it. So that's just the gist of what we do at Sitecore, and I've been a longtime fan of these guys and the support that Azure provides to us, and I'd love for them to tell us what they're doing for us in Azure.
Awesome. Thank you, Jeff.
Absolutely.
Let's give Jeff a big round of applause here.
Thank you.
So Jeff brought up some very real problems that we navigate as trade-offs when we build these multi-tenant SaaS applications. And a lot of times what I hear from our customers is like, hey, I want really good isolation, but at the same time, I also want really good manageability and cost efficiency. And the challenge here is trading off A or B kind of sucks. Why can't I have A and B? And so one of the things that we're innovating on the Azure side is we're building some new things, especially on the data tier, to soften that trade-off around multi-tenancy. And so what I'd love to do is introduce Deborah Chen, who's going to walk us through some of the awesome new capabilities.
Thank you so much, Andrew, and thank you so much, Jeff. My name is Deborah. I'm a product manager on the Azure CosmosDB team. So what I'm excited to share with you today is some of the investments we're making in CosmosDB. So remember, this is the database that Jeff mentioned is using content services, where they have, you may mention, one CosmosDB database account per each organization. And as organizations grow, you can imagine it might get expensive to have this kind of isolation, right? So what we're doing in Azure CosmosDB is with our new Fleets feature, which is now generally available, we're going to soften this trade-off. We're going to give you the ability to have this isolation at the CosmosDB database account layer, so you get all the goodness of being able to provide customer-managed keys, but we're going to make it cost-effective as well, right? That's the magic word in multi-tenancy. It needs to be cost-effective. So what we've actually added is the ability to create a fleet and share throughput or RUs across all of the resources. So in CosmosDB, you provision RUs per second as the unit of performance. So bigger workloads need more throughput, smaller workloads need less throughput. And basically what you find in almost every single multi-tenant system where you have many different customers accessing your site or product at the same time is that they actually don't access your site or product all at the same time. Right? At any given time, you might have a few customers concurrently using your site, but it's pretty unlikely that if you have 100 customers, they're all literally spiking to their peak usage at exactly the same time. And that's exactly the observation we had and what we're doing with our pooling feature, which is part of Fleets. If you look at the usage at any single point in time, cumulatively, that usage is way less than all the sum of your peaks here. You can see on the right-hand side, it's only about 30–40% if you added up all the peaks together. And what pooling will let you do is share throughput capacity across all the resources. So if you have 100 CosmosDB accounts, share throughput across all of them, so you don't have to over-provision every single resource, and that's how you're going to leverage the economies of scale. Now, you're probably thinking, but what about noisy neighbor, right? You can't really have a talk about multi-tenancy without bringing up noisy neighbor. The way we're going to solve this is you're going to still get the benefit of being able to share throughput, but you probably still want some level of guaranteed performance on every single one of your accounts. So we still have the ability for you to provision that dedicated throughput. That throughput and performance is only available for that single tenant or that CosmosDB database account. That's only for it, no sharing. That's always guaranteed no matter what's happening. And then if that's not enough, right, it's hard to predict exactly what everyone needs all the time, then that's where the shared pool can go ahead and cover it. All right. So I'm going to show a picture, and then I'm going to go into a demo. In terms of what this looks like, we have a new resource in our resource provider called a CosmosDB Fleet. It's just a metadata container for organization. So it's a high-level entity that you can basically use to group your accounts into a subgroup called a fleet space. Fleet space is basically where you'll set up your pool of throughput. So typically, if you have different types, similar kinds of tenants or CosmosDB database accounts that need the same performance characteristics, for example, you might have a free tier set of customers who you don't really need to worry about their performance too much, and you might have a set of your enterprise customers who've actually signed contracts where you still want to get cost efficiency of sharing throughput, but you'll probably want to have more pool throughput for those customers. So you can group your similar types of customers into a group called a fleet space. And in that fleet space, you can configure the optional pool of throughput, which will be shared by all the resources inside. This is now generally available, so if you haven't tried it out, please check it out, especially if you're building any kind of multi-tenant application where you have this typical traffic pattern. All right, so I'm going to switch over to my machine. Can I just get a thumbs up if the machine actually switched? People are seeing it? OK, you can see the portal. All right, let's take a look at what this looks like. So here I have my CosmosDB fleet resource. So if you search CosmosDB fleet, you find a new top-level resource right here. And in this fleet I've already created, the first thing I've done is I set up 3 different fleet spaces. Fleet spaces is that boundary of throughput pooling, and it's where I'm going to group similar kinds of tenants. So here I have a free tier fleet space where I'm going to put my free tier customers, commercial, and then enterprise. Within the fleet space, this is where I configure pooling. The pools are autoscale, so if you're familiar with CosmosDB, that should be pretty familiar. But basically, the pool will only scale to what you actually use. All right. Within the fleet space, that's where you add the accounts. So here I've already added, these are 10 different CosmosDB database accounts. Each of these accounts can store data for a different customer, and that's where you can enable things like customer managed keys for each one. We have programmatic ways for you to do this through PowerShell and CLI, but if you want to go through the portal, you can just pick your fleet space, hit accounts to add, hit the accounts, and add them to the fleet space. And really, once you add them, they're just automatically part of the pool. So any dedicated throughput that you've provisioned on the container stays there, but now they can consume from the shared pool. So you get to avoid over-provisioning every single resource, right? Because that's what makes isolation expensive. The fact that you have to provision and keep resources for dedicated performance or throughput for every single resource. But now you can get cost efficiency by sharing the pool. I just want to illustrate this traffic pattern with a few more accounts here. So here, unlike the diagram, I've added 10 different accounts, each of them spiking to a peak at a different point in time. But you can see, like in most multi-tenant applications, if you have 10 customers, they're not all literally spiking to their peak max all at the same time. And in fact, if you actually take that same data and look at each tenant's peak at any given time, so here's a customer, let me zoom out a bit, 1, 2, 3, 4. If you actually add up all of their cumulative usage, you'll see, if you actually do the math, it's about 38% the sum of all those peaks. Right? And that's just with 4 accounts. As you add more and more customers, you get more and more efficiencies and economies of scale as the pooling effect really increases there. So really, call to action, if you have any kind of multi-tenant workload where you're debating, oh, I want isolation, but it's going to be expensive, or but I don't want to have just all my customers share in the same account because it's hard to manage noisy neighbor, this is a great way to soften the trade-off and explore CosmosDB. Now, in addition to this pooling feature, we've also made some investments to improve the monitoring and observability experience. So if you imagine that you have 100 or 1,000, or even as some of our largest customers have 10,000 CosmosDB database accounts and 30,000 containers, right? How are you going to manage and monitor that at scale? It's like looking for a needle in a haystack. You can't go to the Azure Monitor portal and click on every single resource and see, hey, which one might have some issues or could be optimized? Which one should I pay attention to? So what we've done is with Fleet Analytics, which is another feature as part of the fleet, you can configure your fleet to send data to a Fabric workspace or a Azure storage account. So you just go to the Fleet Analytics setting. And you can basically configure the fleet to automatically send some usage, cost, and telemetry data to either a storage or Fabric workspace account of your choice. Here I've already set it up for Fabric, and what it does is it'll basically, if you've ever used Azure Monitor metrics and looked at things like, for each CosmosDB database account, how many requests are happening? Are they reads, writes, queries? How many request units are happening? Consumed? What are my settings across all of my resources? Are they autoscale? Are they manual? What's my backup strategy? We have all of that metadata here at a 1-hour grain. So you can use this to look at the history and monitor the performance of your fleet at scale. So we have some built-in dashboards that you can leverage, but all that raw data is stored in Parquet files, so you can use the Spark client of your choice to basically read them and run your own queries, or use our sample queries. And you can use that to answer questions like, which of my 10,000 CosmosDB database accounts have the most traffic volume or are the most active? How many accounts and databases do I even have? And how many % of my collections are using autoscale? This is super helpful when you know I want 100% of my accounts to be using, say, continuous backup. I think I have enabled that feature globally, but there might be a few that I missed, right? And that's probably this 0.1% over here. We also have a built-in dashboard besides this overview page to suggest potential optimizations that you might make to your fleet. So typically, optimizations come in either performance or cost flavor. A really common question we get is, hey, I'm seeing this bill in Cosmos DB. How do I debug it? How do I make this more efficient? Here we've given you some information on unused accounts. That's probably a big offender. Here in this sample example, I have a bunch of accounts that have 0 data storage, but they have a monthly cost next to it. So you can go figure out who those teams are and reach out. We also have a list of all the collections that have actually never scaled beyond the autoscale min. So in Cosmos DB, you set up autoscale with a range. If you're always at the low end of the range and never scaling up, probably means you can lower the range and save some costs there. It's pretty easy to find this one-on-one if you just have one container. But when you have, honestly, beyond 10 containers or even 30,000, it's really difficult to find these. So with all the sample data, we've built some visualizations and queries for you to leverage that. So that's what I have to show you. Again, if you are building a multi-tenant application and you're using Cosmos DB, take a look at our new fleets feature. We're really excited to make it generally available today. All right. With that in mind, I'll turn it over back to Andrew and Jeff so we can open up. We've got about 8 minutes or so for some Q&A.
Cool. Thank you, Deborah. So we have a microphone up here in the middle, and if you have any questions around some of the lessons learned from Sitecore building real-world multi-tenant apps on Azure, or if you have any questions for Deborah and myself on where we're headed with Azure and especially Cosmos DB, please come up and ask away. Oh, sure.
So in your design, I didn't see anything about API management. Is that something that's not there?
API management in what sense?
So that's where you can throttle and where you can say, based on keys, who has access. You have analytics for API requests and everything.
Yes, I mean, we have all that, but it's all kind of custom.
I'd
have to understand. I mean, we don't use the API when I heard that, I heard Azure API Management Tool. We don't use that. So we could go into why, but we already had a lot of that stuff built at the time.
Is it hidden in the app services maybe, or in the AKS?
Ask one specific thing. So you want to know about rate limiting or?
No, so after the app gateway, you should have the proxy receiving all the APIs.
Yeah, so with app services, it's a direct connection between the app gateway and the app services. You don't have to set anything else up for that.
So there's one backend for every customer?
All the persistence is in SQL Server then. So there's one single app service plan for each environment, and that scales. So it dynamically scales the number of instances, but that's, again, it's just something that we configure. That's, to me, one of the brilliant things about app services. You don't need that expertise in-house to figure that out. You configure it based on CPU and memory utilization is the main thing. So your CPU starts getting close to limits that you set, it'll add another instance. So we get hammered by traffic. The risk there is if you're too lenient if you say, if I get up to 90% memory utilization, that new instance can take some time. So if you get a flood of traffic that comes in, that new instance might not be warm yet, so you might see some degraded performance. But generally, we've just tuned those things over the years just to where we're happy with them. But they're very easy to use. App services, I'm a big fan. Me too. But it's not like every tenant has its own app service, or you have. Nope. That's one of the key tenets that we wanted is simple architecture. So every single API call that comes in has JWT. That JWT has the API client in it. So remember how I said that each tenant can have multiple API clients within it. So the most common scenario would be I run a marketplace. I have an order processing tenant or order processing API client that's for backend processing. I have a front-end buyer API client, and I have my inventory one that I like to complain about because that's a pretty common problem. But you'd have another customer, they would have a different API. They would have the same 3 API clients with different IDs. So that request comes in to the same app service, and it's determined based on that API client what marketplace they're part of, and then the segmentation kind of goes down through SQL Server or Elastic, depending on the query.
And the functions are on a separate plan? Or?
Yes, you don't have to separate them, but we do just because there was no point in keeping them together. And it depends on the size, but for production, we do have app functions in a separate plan. Yeah, but you don't have to. You can. They'll run in the same one.
Thank you.
Yes, of course.
So I think you bring up an interesting topic that maybe I'll also just shed some thoughts on it. Like effectively the topic you're bringing up is I think tenant management. And there's different ways on to how to manage whether it's back pressure or cutting off or trying to mitigate, let's say, a noisy neighbor problem in shared infrastructure. Chatting with Jeff, I learned actually quite a lot about the system. And what I heard from Jeff was in most of their cases, they have wired up really good observability where they're able to determine what the tenant is doing. And often they're able to hotfix, like for example, hey, here is a request pattern I wasn't expecting. I can go and add a SQL index and go and cheapen that request. Or alternatively, if the customer is really doing something very painful, they're also able to go narrow down to the client and govern and block that tenant specifically. Now, with that said, there are many ways to govern a tenant. Right? There's things where you can do like tenant migrations. If you were to go and spin up a whale instance, if it truly was a whale customer, you guys have the infrastructure as code to do that. APIM also offers some knobs and levers that I think are good to be aware of when you're building multi-tenant SaaS applications. Notably, it has built-in rate limiting tools. And so rather than doing like a allow or block the tenant, if you want to go and say, hey, this tenant, I would like to govern in such that they can achieve this many requests per second, but cannot exceed that, APIM does give you out-of-box capabilities for doing so. Now, that does come off with some trade-offs here, which is, I think the thesis of what I learned from Jeff is when you look at cost, isolation, and manageability, you end up many times with a like pick 2 out of 3 problem. And in this case, adding APIM can give us some more manageability, but APIM itself also will add some complexity and cost to the application architecture. I would also highlight there are some other ways of doing rate limiting. Rate limiting is actually something that we have learned intimately building other multi-tenant systems at Azure. Like CosmosDB, the request unit is effectively a rate limiter. One thing I would say as an application developer to be aware of is there's also new rate limiting libraries coming out of the, just baked into the .NET framework itself. They're very powerful, they're very easy to use. If this is a topic that you like going into, whether you're doing like a naive token bucket algorithm or a leaky bucket algorithm, they have tunable libraries now baked into .NET to also help you achieve that.
And if you think about the concept of multi-tenancy, the problem is still the same. When you do rate limiting, you need to base it on some kind of pool. And this is just another pool that you think about is what marketplace the request belongs to.
Cool. Any other questions?
You talked about IAC. I'm just curious what tools you're using for that IAC, what platform, CI/CD pipelines.
That's my favorite topic, so I would love to talk about that. So
Me too.
We actually natively call the Azure APIs using C# because we're .NET developers, and I find that gives us such a lovely granular level of control of our environment. It's not just about running a Bicep or a Terraform to get your infrastructure. We do, I don't want to exaggerate, I would say a few times a month I get pull requests to do infrastructure updates. So a lot of those infrastructure updates require orchestration. So even our releases require orchestration. So we have a big schema change that's going to impact data. We have this kind of multi-step process where we can, change the schema, change some data. We orchestrate every single one of them when there's a problem. I mean, 95% of our releases just go right through and nobody touches it, but sometimes you need to get in there. So it's not just about provisioning, it's also just day-to-day management. So yeah, I really like having that low level of control by just talking right to the Azure APIs. It's more work, but I think it's really worth it because you need that control. Because in these systems, uptime is king. And if you're just pushing a button on a Terraform script, it's not going to give you that level. I'm not a Terraform hater. I know people love it. But yeah, that's my view.
Great.
Yeah, I think we're just about out of time.
Cool. Awesome. Hey, thank you so much for coming to learn how to build multi-tenant applications.
Yeah.
I hope the session was valuable for you. Please give Jeff a big round of applause. And then we'll be hanging out also around if you have any follow-up questions. But otherwise, thank you.